Hello everyone. Today in this video let us discuss about the incompatibilities. This is the most important topic where we will be discussing about what actually the incompatibilities are, its classification, and also we will be seeing in detail about the examples that comes under each incompatibility and also the methods to overcome that. So the incompatibility is nothing but when there is any undesirable product is formed while mixing of two or more substances. When you have mixed two or more substances, if there is a formation of any undesirable product, then we call it as a incompatibility. And this incompatibility, it may affect the safety, efficacy and the appearance of the pharmaceutical preparation. So when it is affecting the safety, efficacy and appearance of the pharmaceutical preparation, then definitely it is a matter of concern to correct that particular incompatibility. So the interaction of the drug with another drug or of a drug with the additives or adjuncts and dosage errors, all these comes under the incompatibilities. And this incompatibility, it may occur at any stage, like it may occur during the formulation development, or it may occur during the manufacturing of the product, or it may occur during the packaging of the products, or even the administration of the drugs, right? So it may happen at any stage of the processing of the drug. So it can be detected. So how we have to detect this particular incompatibility? It can be detected by the changes that you can observe, like physical changes or chemical changes or even the therapeutic qualities of the medicine. By observing these changes, you can identify whether any incompatibility has happened to the drug or not. So based upon these changes, the classification is happened. So the classification of the incompatibilities include physical incompatibilities, chemical incompatibilities and therapeutic incompatibilities. In this particular video, we will be discussing in detail about the physical incompatibilities. So the first one is the physical incompatibility. As the name suggests that it occurs when two or more substances are combined together and an unacceptable product is formed, right? And here this unacceptable compound, it can be visually seen. That is why we call it as a physical incompatibility. And these incompatibility, it may be because of these any of these four reasons. It may be because of immiscibility, maybe because of insolubility or precipitation, or even the liquefaction of the solid material. That means when you have prepared, it is being a solid, but it is turning into the liquid. That is what we call it as a liquefaction of the solid material. And how these incompatibilities, generally, as we say that they are the physical incompatibilities, we will be observing certain physical changes in the product. And how you can overcome or how you can rectify these incompatibilities, it could be by any of these methods. Like you can change the order of mixing of the ingredients. This one you would have observed during the preparation of your emulsions in your practicals. And then by using the emulsification method, like when two substances or when two compounds are immiscible with each other, when you add the emulsifying agent, you can make them as a miscible. And then you have addition of a suspending agent, like for suspensions, change in the form of the ingredients, like if it is in the crystalline form or amorphous form, like that you can change the form of the ingredients, or you can either go with the solid form or liquid form. Like that you can change the form, or else you can either add any of the substance or substitute that substance with the other, or you can directly omit that particular ingredient and you can go for the mixing of ingredients, right? And then let us go in detail about the examples of each type of the physical incompatibility and how we can correct that. So the first one is immiscibility. Here you can take the example as oil and water. We know that in the emulsions we will be having oil in water type and water in oil type, where both are immiscible, but they will be made miscible by using an agent called as an emulsifying agent, right? So immiscibility is nothing but two immiscible phases are there, and those immiscible phases are made miscible to each other within each other by using the emulsifying agent. That is how you can rectify the immiscibility. And then the second and the most important one we have is the insolubility. So this insolubility is nothing but here we can see either the insolubility of organic compounds or the inorganic compounds as well, right? So here first let us see about the inorganic compounds. So here first let us see about the insolubility of the inorganic compounds, and again the inorganic compounds are further divided into metals and their salts and the non-metals. So here in the metals and their salts again we have three categories. They are the alkali salts, alkali earth metals, and then we also have heavy metals. So how these metals are being affected by the solubility, right? So in the alkali metals we can take the examples like what are the alkali metals we have? They are lithium, sodium as well as the potassium. So the general rule here you have to remember is most of the alkali metal salts are highly soluble in water. For example, here you can take the example as sodium chloride plus silver nitrate. Okay, when the sodium chloride is combined with the silver nitrate, it gives silver chloride plus sodium nitrate. So the sodium salts are soluble, but however the silver chloride, whatever it is formed, it forms as a white precipitate. That means it is not able to soluble properly. So why there is an incompatibility here? As this silver chloride is insoluble, when sodium chloride solution is mixed with the silver nitrate, a white precipitate is forming, which is leading to the physical incompatibility. So here you have to remember that alkali metals are soluble, but when they meet the heavy metals like silver, the precipitation may happen, right? That is in case of alkali metals. And coming to the alkaline earth metals, what are the alkaline earth metals that we have? Calcium, magnesium as well as the barium. So here you have to remember that the salts like these alkaline earth metals, they form the soluble salts. Okay, they form the soluble salts with that of the univalent anions. Okay, what are univalent anions? Like Cl minus, NO3 minus, these are called as the univalent anions, and they form insoluble salts. Like alkaline earth metals, they form the insoluble salts with either divalent or the trivalent anions. So what are the examples of divalent and trivalent? SO4 2 minus is the divalent, CO3 2 minus is the divalent, whereas PO4 3 minus is the trivalent anion. So here you can take the example of calcium chloride along with the sodium carbonate. When it is mixed with the sodium carbonate, it forms the calcium carbonate, which forms as a white precipitate, and there also it is a formation of sodium chloride. So here calcium carbonate is insoluble, and you can have another example like magnesium sulfate. When it is mixed with the sodium hydroxide, it is going to give the magnesium hydroxide. It gives the magnesium hydroxide, which forms as a precipitate, and also it gives the sodium sulfate. So here in the magnesium hydroxide, it precipitates. So as the alkaline earth metals, they form the insoluble carbonates, phosphates, hydroxides as well as the sulfates. That is what the incompatibility happens here. That means the calcium and magnesium, they love to form the insoluble carbonates as well as the hydroxides. And the third category under the alkali and their salts we have is the heavy metals. So heavy metals are nothing but where we have zinc, mercury, okay, and then lead. Like that we have various heavy metals. So the major cause of the incompatibility in pharmacy here with the heavy metals is they commonly form the insoluble salts. For example, if we take zinc sulfate along with that of the sodium hydroxide, it is going to form zinc hydroxide. It is also again a precipitate, white precipitate along with that of the sodium sulfate. Okay, so this is how it is going to form the insoluble one. And with mercury also you can have the examples like for example mercury chloride along with that of the sodium hydroxide, it is going to form the mercury hydroxide, which is again it is very unstable and also it forms the yellow precipitate. In the same way we have the examples with lead acetate, sodium sulfate. If you write one or two examples, it is more than enough, right? So the physical incompatibility, it mainly occurs when two soluble salts are mixed and an insoluble product which is formed as a precipitate, right? So here, and the next one we have is the organic compounds, like, so we have insolubility of organic compounds, and under this again we have three classes. The first one we have is the hydrocarbons, and then we have compounds solubilized through hydrogen bonding and polarization, and the third category we have compounds solubilized through ionization. So one after the other we shall just see about these things. So the hydrocarbons, whenever except the hydrocarbons, all the organic compounds, they generally possess both the polar as well as the non-polar parts, right? So their solubility, these organic compound solubility, it mainly depends upon the balance between these two parts. How well they are going to balance these two parts, it shows the solubility of that particular compound. So organic compounds which are soluble in water, they must possess the groups which are capable of forming the hydrogen bond, okay, because whenever there is a formation of a hydrogen bond, the solubility will be proper. So first in the hydrocarbons, these are completely non-polar in nature and they are not soluble in water and they are soluble in the organic solvents or the non-polar solvents. They are soluble in the non-polar solvents, right? And the second category we have is the compounds solubilized through hydrogen bonding and the polarization. So these are the second category of the organic compounds. So here we will be getting the compounds like alcohols, okay, phenols, carboxylic acids, right, amines, aldehydes, right, ketones, esters. So all these, they possess the water solubility because all these compounds, the mentioned compounds, they have the capability of forming the hydrogen bonds, right? And these compounds, they show increase in the solubility in ethyl alcohol because they form the additional non-polar bonding with the compound. So under this again we have various categories, like the first one is the monofunctional alcohols. So under monofunctional alcohols we get ethyl and isopropyl alcohol. Examples are the ethyl and isopropyl alcohol. So here both the compounds, they show complete solubility in water, whereas alcohol with 4 or more carbon atoms, they show reduction in the solubility in water. That means as the number of carbon atoms are increasing, there will be reduction in the solubility in water. This is the monofunctional alcohols. And then we have polyfunctional alcohols. So in the polyfunctional alcohols, the additional hydroxyl group increases the water solubility of organic compounds of higher molecular weight, right? So as and when there is a increase in the hydroxyl group, the solubility of the compound increases. And then the third category we have is the glycols and carbohydrates. Generally, these are water soluble or water dispersible. Here we can have the examples of glycerin, ethylene glycol, gums like acacia, agar, tragacanth. All these comes under this category. And then the next one we have is the phenols. So these phenols, as you know, they consist of one hydroxyl group, right, on a benzene ring, and this is very slightly soluble in water. Increase in the hydroxyl groups, increase in the number of carbon atoms, and that results in the increased solubility. So increase in the number of hydroxyl groups, there will be increase in the solubility. And then the next one we have is the carboxylic acids. So coming to the carboxylic acids, the solubility of these compounds, it depends upon the hydrogen bonding but not on the ionization. Like simple organic acids with one carboxylic group, they are infinitely soluble. Like for example, formic acid, right, and acetic acid. Whereas higher acids, they are alcohol soluble. Like for example, stearic acid. Okay. And then the next category we have is the amines. So here the solubility of amines, it depends upon their ability to form the hydrogen bonding again. Whereas aliphatic amines, they show slightly higher solubility than that of the aromatic amines. It's simple. That is, aliphatic amines, they are more soluble than the aromatic amines. Aliphatic, aromatic. Aliphatic are the open chain, aromatic are the ring chain. Ring structures. And then we have the aldehydes. So aldehydes, they possess the considerable water solubility because of the hydrate formation. Examples include formaldehyde and chloral hydrate. And then we have the ketones. So here ketones, example, the most favorite example for ketone is the acetone, which is completely soluble in water. This is the example for the ketone. This all comes under the second category, where the solubilization is happening because of the hydrogen bonding and the polarization. And then the third category we get is the third category is the compounds that are solubilized through ionization. Compounds solubilized through ionization. So here all the salt forms of the drugs are soluble in water because of their ionization. Ionization is nothing but formation of the ions. So here we have few examples where solubility in water is increased because of the salt formation. The first example is the salts of phenol and carboxylic acid. That means here you have to remember that instead of the solubility of phenol and carboxylic acid alone, the salts of phenol and the salts of carboxylic acids have better solubility. Okay, so they get dissolved readily in the aqueous solutions of bases of alkali metals through the salt formation, like sodium salts. Examples are the sodium salts of phenols, resorcinol, benzoic acid, salicylic acid. All these comes under this category. And the second group we have is the salts of sulfonamides. Okay, we have the salts of sulfonamides. Here the sulfonamides, they form the salts with alkali metals. Okay, they form the alkali metals because of their acidic nature. So the sodium salts of these sulfonamides are the water soluble one, but they react with acids to precipitate the insoluble acidic sulfonamides. And then the third category we have here is the salts of amines. So these salts of amines, like amines, they form the water soluble salts in the presence of mineral as well as the organic acids depending upon their basicity. Like for example, many local anesthetics, alkaloids, surfactants, phenothiazide derivatives, they form water soluble salts in the presence of the acids, and they try to precipitate the free base in the presence of the alkali, right? So this is how we have the solubility of inorganic compounds, where it has been divided into the metals and the non-metals, and the solubility of organic compounds, again we have the three categories. And then the third physical incompatibility that we have is the precipitation. Okay, the third category is the precipitation. So whenever a drug in solution, it can form as a precipitate if the solvent in which it is insoluble, it is added to the solution. Like for example, you take the resins. Okay, these resins are insoluble in water. Okay, they are insoluble in water. So when tincture containing this resinous matter, it is added to the water, this resin, it agglomerates, forming the it forms the precipitate. How you can prevent this particular one? This can be prevented by slowly adding. Okay, if you remember in the beginning of the video, we have discussed how you can overcome these physical incompatibilities by changing the order of mixing, by changing the form of the ingredient, like that we have discussed, right? So this precipitation here, especially in case of the resins, it can be prevented by slowly adding the undiluted tincture with rigorous stirring to the diluted suspension, or even by adding certain amount of the thickering agents. And also there are certain gums called as the acacia, tragacanth, agar. Okay, like that we have certain gums which are precipitated from their alcoholic solutions by these products, acacia, tragacanth and agar, they are precipitated from their aqueous solutions by adding either alcohol or by the electrolytes through the dehydration process. Okay, and then the fourth category we have is the liquefaction. So liquefaction is nothing but, example you can take here is the your most favorite eutectic mixtures. So these eutectic mixtures are nothing but when certain low melting point solids are mixed together, a liquid or soft mass called as a eutectic mixture will be formed. So when two compounds of different melting points are added together, there will be the formation of a third compound whose melting point is less than the individual of these two compounds, right? So then what you will be doing here, our most favorite example is the menthol, camphor, right? For example, you have a prescription consisting of menthol, camphor, ammonium chloride and light magnesium carbonate. So here in this prescription, the menthol and camphor ammonium chloride, they get liquefied on mixing with each other. So in order to dispense this prescription, menthol, camphor and ammonium chloride are triturated together to form a liquid, and then this magnesium carbonate is added to this mixture in order to form a free flowing powder. In this way you can reduce or you can overcome the liquefaction type of the incompatibility, right? So this is all about the complete physical incompatibility, a very important topic that you have to focus on. Thank you.